Okay, let's go over some of the problems on the practice test. The first one said to simplify negative 3x times 2x minus 5. So you have that negative 3x times 2x minus 5. And this negative 3x multiplies by the 2x. And the integers multiply to get negative 6. The x times x is x squared. And now you have negative 3x times negative 5. So negative 3 times negative 5 is positive 15. And then this one has an x, so we put the x there. The second one was a binomial, and it was two binomials, 3x minus 1, 2x plus 5. So the idea behind this is both terms here get to multiply by both terms here. So 3x takes its turn first, then negative 1 takes its turn after that. So first we do 3x times 2x, then we're going to do 3x times positive 5. So 3x times 2x, 6x squared. 3x times positive 5, positive 15x. Now I look at this negative 1, and I do negative 1 times 2x, which is negative 2x, and negative 1 times 5, which is minus 5. Now the way I've set these up, and I'll continue to set them up like this, is the middle two terms will always be what I call x terms or linear terms, and you'll be able to combine those. So I keep the 6x squared. Positive 15x minus 2x is positive 13x minus 5. And that's my final answer there. The next one asks us to identify if these are linear, quadratic, or exponential. So for number 3, we see that it's a recursive equation, and we know that it's linear. This one is linear because we see this rate of change right here is minus 6. So that means each time you have a term, you subtract 6 to get the next term. So this one's linear. This one's also linear. I used x's instead of t's, but when you have anything that looks like y equals mx plus b, then that is a linear. Notice also that this variable has no visible exponent. So the exponent would be 1, and that's another way that we know an explicit is linear. Here, we have f of t equals 4 times 3 to the power of t. Well, anytime we have an exponent that's a variable, that is an exponential. Number 5, we should recognize this ending of a recursive as making this into a quadratic. So if you have a quadratic and then a rate of change with an n after it, and then maybe some other number, then you have a quadratic in your recursive. So number 7, the shape here is a parabola, so that's quadratic. Number 8, this shape is exponential. It's an always increasing curve that starts to get steeper and steeper as it increases. You can also have an exponential that's an always decreasing curve. This table of values, we're supposed to also know whether this is linear or quadratic or exponential. So what we want to look at is a couple ways to do this. But let's say you looked at the first differences. If you did, you would have gotten plus 10, plus 60, plus some other really big number, plus some other really big number. And the second differences wouldn't have been equal either. But what you would have noticed is whether you're looking at the values or the first difference or the second difference, there's always a times 6 ratio between the terms. So if there's a common ratio between the answers, then we know it's exponential. And in this case, that common ratio is times 6. So exponential. Now when we look at number 10, the question is this the type of function? And then we are supposed to graph it. So, and write the recursive equation. So let's see, we'll do first differences. And what you'll find when you do first differences is that you get +1, +3, +7, +11. And then you find that your second differences are all +4. So this type of function is quadratic because the second differences are all equal. And then the recursive equation would be f of n equals, I'm going to write it down here, f of n minus 1 plus, remember we want to do second difference n plus or minus some mystery number. So we said our second difference was +4. And now it's just up to us to figure out what goes here. So I'm going to look over at the table here, and I think I'm going to use f of n equals, I'm going to use the 4 value. So I'm going to say f of 4. Now I'm going to plug in. Well, f of 4 minus 1 is the same as f of 3. And f of 3 means the answer to 3, which is going to be 7. 4n means 4 times whatever you decided here. And I decided to use the 4. So that's 4 times 4 plus a mystery number. So f of 3 means the answer to 3. And we can see right here that that's 7. 4 times 4 is 16 plus a mystery number. 7 plus 16 is 23 plus some mystery number. Well, for f of 4, we know we want the number 18. So we already know that this is actually 18. So 18 equals 23, actually minus 5. So I can put my -5 here, and then that is the equation. Okay, as far as the graphing goes, I'm not going to spend too much time on the graphing, but let's take a look at this. I'll come back to the f of 5. If you want to graph the first point, you do 0, -2, which means you come to the graph, and x is 0, which means it's going to be along here, and then -2 is here. So your first dot goes right here. The second point on the graph is 1, -3. So that means x has to be x has to be +1, and y has to be -3, which would be in between the 2 and the 4. So a dot here, then 2, 0. Here's my 2. And if y is 0, it means it's not high or low. It's right on the x-axis. 3, 7. Here's my 3. And then I'll go up to the 7, which is in between the 6 and the 8. And then 4, 18. Put my 4 here. 18's all the way up here, so the dot would go there. Okay, so you'll have kind of a partial parabola there. Back to the question about what is f of 5. What is f of 5? Well, we know that f of 4 is 18, and we have an equation that will tell us f of 5. Our equation says that if you want f of 5, you take the answer to the previous one. F of 5 minus 1 is f of 4. And the answer to f of 4, we already know this is 18, plus 5 times n, 4 times n, sorry, 4n. That's 4 times 5, and then minus 5. So I have f of 4, which is 18, plus 20, minus 5. 18 plus 20, 38, minus 5 equals 33. So if I continued this table of values, I would have 5, 33 coming right after my 4, 18. So if we look at the second page of the practice test, we're supposed to write the intervals for domain range increasing, decreasing, and say whether it's a function. So as far as the intervals go, take a look at this graph. The domain is all the x values necessary to make this graph. That's left and right, the furthest left endpoint and the furthest right endpoint. Well, the x value furthest to the left is -5 that I would need, and over to the right is 3. So the way I'm going to write that is using my notation. I know that x has to be between -5 and 3. So I'm going to put x in the less than signs. Okay, you can put less than or equal to on this if you want. If you don't, I won't mark it wrong at this point. So I'm saying that all the x values in this graph have to be in between -5 and +3. There can't be any x values that are like a 5 or a -8. They all have to be in between -5 and 3, the part on this picture. So now I want to know for range, what are the y values? So when you're drawing this graph, or when somebody drew this graph, the lowest y value they needed was -3. There's nothing lower than that that's on this picture. -3 was the bottom. The highest it ever went was right here, +1. So basically all the y values on this graph are in between -3 and +1. So that's how I'm going to write it. Now it also asks us about increasing and decreasing. So for increasing, we want to know, when is the graph going uphill from left to right? When are the y values getting bigger from left to right? And that's happening here. So, and remember I told you that we always use x values for increasing and decreasing. So it starts increasing right where the graph starts at -5. And then it keeps increasing. That is, the graph keeps increasing. I think I'm going to keep going. Let me see if I can fix that. Hope that didn't hurt. We can say that it keeps increasing. It's easier to fix. There we go. From -5 until this point, which, if I'm reading my own handwriting correctly, I think is -2. So from -5 to -2, the graph is going up. So if you are skateboarding on this graph, from here to here, you're having to go uphill. I would say starting at -2, you're going downhill. So the decreasing part of the graph is, let me zoom out here without dropping the phone. So the increasing part of the graph was from -5 to -2. That was the increasing. The decreasing part is starting at -2, and then we're looking at how the graph goes downhill from there, really until it ends at 3. And if you recall in class, we talked about how for domain range increasing and decreasing, the only time we're using the y is on the range. Everything else uses x values. So the next part wants us to write the next 3 terms using the equation that was given. So on 12a, we had f of n equals f of n minus 1 plus 6. And then they gave you the first term, 3. Well, hopefully what you recognize is that the equation that was given is a linear. This is just a linear recursive, and it means take what you already have and keep adding 6. 3 plus 6 is 9. Plus 6 again is 15. Plus 6 again is 21. That's really what you do there. You recognize the rate of change, and then that's how you change each number, because you saw that that rate of change is 6. So the next one has the 3n minus 1. So on this 12b, you have f of n equals f of n minus 1 plus 3n minus 1. Now, to use recursive equations, they always have to give you a starting point. And they told us that when n equals 1, the function equals 2. So when n equals 1, the function equals 2. So we're going to take this answer 2. That's our previous answer, our f of n minus 1, because now we're trying to find n equals 2. So when we try to find, let me do it this way. If we're trying to find f of 2 now, we're going to do f of 2 minus 1 plus 3n, and we decided n was 2 right now, minus 1. F of 2 minus 1 is f of 1. That means the answer to 1. So that's 2 plus 6 minus 1. 8, 7. So when we want the next one, all we have to do is take that 7, because this means previous answer. So when we want this one, 7 was our previous answer. And now we're trying to find the third term. Plus 3 times n, because we're on n equals 3 now, minus 1. 7 plus 9 minus 1. So that's 16 minus 1, 15. And then one more. To find the n equals 4, we take this 15, then we go 3 times 4 minus 1. 15 plus 12 minus 1, 27 minus 1, 26. Now, since that's quadratic, if you had the time on the test, you could check your second differences, right? Because your second differences should turn out to be 3. Here's a 5. I'm just doing first differences. 8. What is that? 11. Second difference is 3. Second difference is 3. I'm happy because math worked just then. The third one is an explicit exponential. Now we're supposed to find x equals 0, x equals 1, x equals 2. Well, actually, they gave us f of 0. So let's find f of 1. Doesn't even matter if we know f of 0 or not. It would be 2 times 3 to the power of 1. That's 2 times 3. So f of 1 is 6. So our sequence that they already gave us, they gave us 2. And our second number is going to be 6. And we don't even have to know that 6 to find the next one. Let's find f of 2. 2 times 3 squared. Now remember, PEMDAS says we can't multiply yet. We have to handle the exponent first. So this is 9. So 2 times 9. 18. Oh, hey, is there a pattern? Yes. This is our rate of change. All we're doing every time is multiplying by 3. So we should be able to get this last answer by going 18 times 3 or by using our equation. So let's use our equation. 2, this is the third, because they said this one was 0. X equals 0, x equals 1, x equals 2. So for x equals 3, 3 to the power of 3. Remember, that's not 9, that is 27, because 3 times 3 times 3 is 27. And that's 2 times 27. Notice I handled the exponent first. Now I'm multiplying by 2. 27 times 2, 14. 2 times 2 is 4, 54. And if you multiply each of these by 3, you get the next term. So you see that the rate of change keeps working. Number 13, we're supposed to find the slope. So to find the slope on 13, you need to take your y2 minus y1 over x2 minus x1. When you have two negatives in a row in the middle of a problem, you change them both to positives. But now we have negative 20 plus 8. Negative 20, positive 8. The signs are different. So that means I do 20 minus 8 and take the sign of the negative. Okay, or if you're using a number line, if you're at negative 20 and you have to move forward 8, you're going to end up at negative 12. And then 9 minus 5 is 4. We simplify, and we get negative 3, or negative 3 over 1. Next we have rate of change, and we have x equals negative 1, x equals 3, and the function that was given is f of x equals 4x squared minus 3. Remember, there are 2 steps for this. You need to get an ordered pair. You need to get 2 ordered pairs, right, by substituting. And then you need to do slope. That's a very short version of that. So they told us that one of the x's was x equals negative 1. So for f of negative 1, 4 negative 1 squared minus 3. Anything squared turns out to be positive. Negative 1 times negative 1 is 1. Remember, I'm doing the squaring first. So 4 times 1, because negative 1 times negative 1 is positive 1, minus 3, 4 minus 3. So one of my ordered pairs is negative 1, comma 1. Then the other x value they told us was x equals 3. 4 times 3 squared minus 3. Remember, you have to square first. Don't do 12 and then square. You have to take care of the exponent first. Parentheses are really first, but there's nothing to do here. It's a 3. So now I'm going to square the 3. That gives me 9. So I have 4 times 9 minus 3. 36 minus 3, 33. So my second ordered pair is the x value is 3, my y value was 33. So now I need to do a slope formula, because that's really what we're doing. So this is x1, y1, x2, y2. So on top, 33 minus 1. On bottom, 3 minus negative 1. 32. These change to positive because it's 2 negatives in a row. 4. Final answer, 8. So that is the average rate of change. Then last one, greatest common factor. So they gave us 18 k to the power of 6, m to the power of 2, n to the power of 7, and 10 k to the power of 7, m to the power of 5, n to the power of 3. So we're looking, when we look for greatest common factors, we're looking for what is the greatest number, integer, that both of these are divisible by. I can divide them both by 2. I cannot divide 10 by 3. I cannot divide either of them by 4. I can divide this by 5, but not this. I can divide this by 6, but not this. No 7s, no 8s. This one has a 9, but this one doesn't. So, I mean, I feel like that's the way most people think of it, is they just kind of run through their times tables. But the longer way to think of it is to go ahead and factor it out. So this is 9 times 2. And then that becomes 3 times 3. By the way, I always bring my number down so they're all together. 3 times 3 times 2. 10 is just 5 times 2. So if you look at the final factorization of each one, when it's factored down as far as it can go, the only number they have in common is 1, 2. Okay, so that's the greatest common factor between 10 and 18. That's a 2. Now, the letters are much easier. This one, k to the 6th, is literally k times k times k times k times k 6 times. One more. And this is k times itself 7 times. So what do they have in common? Do they have 1k in common? Yeah. Do they have 2 in common? Yeah. 3, 4, 5, 6. They have 6 of them in common. This is k to the 6th. This is k to the 7th. So they both have k to the 6th included in them. So k to the 6th is the greatest thing that these have in common. I think I was telling one class, think of it like this guy has a PlayStation 6 and this guy has a PlayStation 7. So the best games you can play on both machines are PlayStation 6 games. You know, what's the highest thing they have in common? So then between the 2 and the 5, what's the highest thing they have in common? Just the 2. And some people were saying, well, don't I subtract or whatever? I'm not in this realm. We're just looking for what's the highest exponent now that they have in common. And then the n's, they have n to the 3rd power in common, because this one has n times n times n, and so does this. So they have n to the power 3 in common. So find the common factor from your integers, and then for your exponents, you're really just selecting the smaller of the 2 exponents, because that's the most that they have in common. All right, that was the whole practice test. I hope this has been helpful.